Now I wanted to talk about the reason why this adjustment is used when the data comes from a sample. When a person is doing a study and the person collects data from a sample, the person will typically calculate the mean and the standard deviation of the sample to estimate what the mean and standard deviation of the entire population equals. So when a person calculates a sample mean, the person is trying to estimate the population mean. And when a person calculates a sample standard deviation, the person is trying to estimate the population standard deviation. So here's an example. Imagine I record the heights of 100 JFK students, and I use those 100 heights to calculate the mean and the standard deviation of my sample. What I would do is I would use that sample mean as an estimate of what the mean height of all JFK students equals, and I would use the standard deviation of my sample to estimate what the standard deviation of all JFK students equals. In other words, I would use my sample mean to estimate the mean of the entire university, and I would use my sample standard deviation to estimate the standard deviation of the entire university. Now, if I used a decent sample size, my sample mean should do a pretty good job of estimating the population mean. My sample mean should fall pretty close to what the population mean equals. But it turns out that my sample standard deviation will only do a good job of estimating the population standard deviation if this adjustment has been used. If I didn't use this adjustment and I divided by n instead of dividing by n minus 1, I would expect my sample standard deviation to underestimate the population standard deviation, and I would expect my sample standard deviation to come out too low. So in order to reduce the chance that my sample standard deviation will end up underestimating the population standard deviation, I have to do an adjustment that boosts my sample standard deviation up to a higher number. And if I divide by n minus 1, what I'm doing is I'm dividing by a smaller number, which ends up causing me to get a bigger answer. And that bigger answer is less likely to underestimate the population standard deviation. The reason why there's this tendency for the sample standard deviation to underestimate the population standard deviation is because the population standard deviation is based on the amount of spread that exists across the entire population, from the lowest person all the way up to the highest person. When you take a sample of a population, you tend to get not enough of the extreme people in the sample, because those extreme people are it's harder to come across them because there aren't as many of them out there. And if your sample doesn't include enough of the extreme people down here or enough of the extreme people out here, then your sample doesn't really represent the true spread of the population. Your sample ends up having less spread than the entire population does. And because of that, your sample, the standard deviation of your sample will actually underestimate the true spread of the entire population. And so that's the reason why the sample standard deviation tends to come out lower than the population standard deviation. Because the population, because the sample doesn't really truly represent the true amount of spread that exists across the entire population. In order to make it so that the sample standard deviation does a better job of estimating the true population standard deviation, sample standard deviation has to be adjusted upward to a higher number, and that's what this n minus 1 does. It boosts the sample standard deviation so that it does a better job of estimating the standard deviation of all population members. Now the sample mean doesn't have to have an adjustment. The mean of the data is calculated the same way regardless of whether it's a population or a sample. So you don't have to have an adjustment when you're calculating a sample mean, because the sample mean will do a good job of estimating the population mean even without any type of adjustment. But it turns out that the standard deviation of the sample does need an adjustment for it to do a good job of estimating the population standard deviation. So you can think of it this way. If I repeated my study over and over again, and I kept calculating the mean of each sample, in other words, if I kept taking more and more samples from a population, and each time I take a sample, I calculate the sample mean, what's going to happen is some of those sample means will come out too low and underestimate the population mean. Some of them will come out too high and overestimate the population mean. But overall, they'll tend to fall within a certain range of the population mean, like they are here. If so, here is a different sample mean, the mean of a different sample. Now, if I take more and more samples from a population, and I calculate the standard deviation of each of my samples, then if I don't use the adjustment, the n minus 1, what's going to happen is most of the standard deviations that I calculate are going to end up too low. In other words, if this is the population standard deviation, then most of my samples are going to end up having sample standard deviations down here. Most of the time, the sample standard deviation is going to come out lower than the population standard deviation. Now, a few of them will come out higher. A few of them will overestimate the population standard deviation, but most of them will pile up down here and underestimate the population standard deviation. So this is with no adjustment. I'm talking about if the adjustment isn't used. If the adjustment is used, meaning if I took a bunch of samples over and over again, and I calculated the standard deviation of each sample, and I calculate each standard deviation with the n minus 1, what's going to happen is there's no longer going to be this tendency for the sample standard deviation to come out too low. They'll end up looking more like this, with about half of them on this side and half of them on this side. That's if I'm using the n minus 1 each time I calculate a sample standard deviation.